In this section, we will take a look at two higher order functions, map and fold. Both functions are predefined in Reason and are commonly used for list transformations. We will take a look at how they work under the hood and see some examples of their usage. But first, let's talk about the list module. The list module in the standard library provides us with many predefined functions which we can use for our computations. All these functions are polymorphic, so we can use them on lists containing any types. This is possible because lists themselves are polymorphic variant types, so the functions working on lists also have to be polymorphic. And map and fold functions are also part of this module. Let's start with the map function. The map function allows us to transform a list by applying the same function to all elements of the list. And it's already predefined for us in the list module as list.map. However, because it's useful to see how it works under the hood, we are going to define it ourselves. Our map function expects two arguments, a function with a single argument and a list. It's a recursive function because it starts with the rec keyword. It takes these two arguments and applies past function to each element of the list using recursion with pattern matching. And since the list variant has two constructors, we need to address both in pattern matching, as you can see here. Finally, the map function returns the transformed list as the result. We can also deduce this behavior from the type of our function. As any other list function, the map function is polymorphic. As you can see, the first argument must be a function with a single parameter. The second argument is a list containing elements of type alpha. And because the past function will take elements from the list, it also expects the parameter of type alpha. And it returns the type of beta. This means that the returned value of the map function will be a list of betas, as you can see here. Let's call our map function to see this in action. We defined the add function, which expects an integer, adds 5 to it, and returns a result. Then we pass this function as the first argument to the map function, along with the list as the second one. In the function, we pattern match the past list. And since it's not empty, we go to the second case. Here we take the first element from the list and pass it to the add function, which is here as a func parameter. This function will add 5 to it. At the same time, we call the map recursively with the add function and with the rest of the list without the first element, and this is called tail. So each recursive call, the list is getting shorter, and when the list is empty, we will compute and return the new transformed list where the value of each element is increased by 5. Let's now create a function that maps two lists. We defined the map2 function, which expects a function and two lists. In the function, we use pattern matching to extract the element from the first and second list at once and pass them to the func and do the recursive calls. Finally, the map2 function returns a single transformed list as the result. We might also encounter a runtime error, since it might happen that both lists are of a different length. In this case, we have this raise construction which raises an error, and we will learn more about this in the upcoming sections. Let's call our function. We want to do similar thing we did with the normal map function. However, in this case, we want to add elements from two lists together. So we change the add function because map2 expects a function with two parameters. Moreover, both list arguments must be of the same type, in our case integers. We need to do this because the passed function will be applied to two elements which occur at the same position in the both lists. When we called map2 and passed it the add function and two lists of integer, we first pattern match these two lists. Then we took first elements from both lists and passed them to the add function, which added them together. By performing this operation recursively, we were able to add both list arguments together. So our function returned a single list whose elements are elements from these two lists added together. However, we can add two lists of integers together more concisely. In this example, we don't need to use the add function to add two lists together anymore. We just need to pass the plus operator instead. However, arithmetic operators themselves cannot be used like normal functions, since they have an infix notation, which means that operators are written in between their operands. Fortunately, we can transform them into functions by writing them between parentheses. So when we pass the plus operator and two lists to the map2 function, we get the same result as before when we use the add function. Moreover, we can make this function reusable using the partial application. As you can see, we first passed the plus operator to map2 and got back a function expecting two lists of integers. Then we called this function with two lists and we got back our result. And then we called it again with different lists, and again it worked. Map functions are really versatile since we can also combine them to elegantly add two sublists of integers together. Let's take a look. Here we passed the map2 function and a list of lists to another map2 function. Then we partially applied the inner mapping function by passing it the plus operator. Then the outer mapping function took the partially applied inner mapping function and applied it to all elements of the list. So to each pair of our nested list. By doing that, we were able to access individual elements of these pairs and add them together. So the logic is the same as in the previous example. We just used another map2 to access nested lists.